Hey, Miss Miklos here with lecture number 19, and this is going to be our third way that we are learning to solve systems of linear equations. This particular method is the final Algebra 1 method you guys have learned. Our next lecture is going to be something brand new, but this is going to be on linear combination. Linear combination is my personal favorite of the three ways that we've gone through so far. The nice thing about linear combination, it's useful if the problem is written in standard form. As always, fractions can just be a pain in our butt, so that is going to be the biggest disadvantage when we have fractional answers. So the key thing for us is we want to get either the x's or the y's to cancel out. So I'm going to multiply one or both of the equations by a constant to obtain coefficients that are the same but opposite signs. For example, as we kind of walk through our steps, I'm going to show us on example 1 here, which is done out for us. I decided on this particular problem to eliminate my y's, so I multiplied this first equation by 4, and I multiplied this second equation by 3. These are my two new equations. Now we can see these y's are both 12, but they are opposites. The second step is I'm going to add these two equations together. So 20x plus 6x is 26x. Notice my y's cancel out. Every single time, one of the two variables should cancel out. If not, that means you did something wrong. Here, I'm going to add 28 and negative 54, and I get negative 26. Now I'm going to just solve this equation for our remaining variable. So when I divide by 26, I get x equals negative 1. Now I can substitute into either of these two equations. I chose to use the first one. And when I substituted in for x, I got that y was equal to 4. So the final thing we're going to do is write our answer as an ordered pair, negative 1, 4, and then as always I should double check and see if that works. So in this case, negative 5 plus 12 is 7. That works. And negative 2 minus 16 is negative 18. So that works. So let's go ahead and move on to number 2. Okay, so number 2, this is both equations here are in standard form, so I think that using this particular method of linear combination, you guys may have also learned this as elimination. It just depends what the book calls it. I think that method will be appropriate. I'm actually going to choose to cancel out my y's here. The reason being, even though these are fractional, I notice that if I multiply negative 2/3 by 2, it is 4/3. So what it's going to do, it's actually allowing me to only multiply one equation, which is just less work. If I wanted to cancel out my x's, I definitely could. I would have multiplied this equation by negative 3 and the bottom equation by 2. It does not matter what method we choose, If I do my algebra correctly, we will get the same answer. So I'm multiplying this top equation by 2, so I get 4x minus 4/3 y equals 24. So now I need to add these together. When I combine these, I get x, my y's cancel out, and I know that negative 17 plus 24 becomes 7. So I have x equals 7. So I'm going to go ahead and write 7 in my ordered pair. Now I can choose either one of these two original equations. It doesn't matter. I'm just going to use the first one. So I'm just going to rewrite 2x minus 2/3 y equals 12. And I'm going to substitute 7 in for x. So when I go ahead and multiply this, I get 14 minus 2/3 y equals 12. When I subtract 14 from both sides, I get negative 2/3 y equals negative 12. So I'm going to multiply both sides by negative 3/2 because I know that these are reciprocals of one another, and I end up getting y is equal to 3. So if I move back, I'm going to write my ordered pair here as 7, 3, and let's double check if this works. I would get 14 minus 2 is 12, which is true. Then I would get negative 21 plus 4 is negative 17, which is also true. So I know that 7, 3 is my solution. So once again, I did this by eliminating my y's by multiplying this top equation by 2. Let's take a look at number 3. Number 3, we have an option once again. I can either eliminate the x's or eliminate the y's. If I eliminated the x's, I would multiply this second equation by negative 4 because that would give me x's that would cancel out. If I choose to eliminate the y's, I would multiply this top equation by positive 2 because that would give me variables that would cancel out. I'm going to eliminate the x here just to show it doesn't matter if we eliminate x or y. So I rewrote our first equation, and when I distribute negative 4 to that second equation, I get negative 4x plus 8y equals negative 32. So I'm going to go ahead and add these together. My x values cancel each other out, and I'm left with 9y equals negative 27. When I divide both sides by 9, I get y is equal to negative 3. I just want to stress how important it is to take our time on our values. If I get 3, even if I do everything else correctly from here, I'm going to get a completely incorrect answer. So now I can substitute negative 3 into either of these two equations. I'm actually going to choose the second one. So I'm going to write x minus 2 times negative 3 equals 8. So I get x plus 6 equals 8. So x is equal to 2. So that's telling me that my solution should be 2, negative 3. Let's double check. 8 minus 3 is 5. 2 plus 6 is 8. So it does work in both equations. 2, negative 3 is our solution. So moving on to number 4. I'm going to cancel out my x's here, so I'm going to multiply this top equation by negative 2. So I would get negative 4x minus 6y equals negative 20. And something kind of strange happens here because my x's and my y's both cancel out and just leave me with 0 equals 0. Let me erase that. There we go. 0 equals 0. So in our last lecture, we said when our variables cancel, we need to ask ourselves, is this true? Yes, this is true, which means they are the same line. So my answer is going to be all the ordered pairs on the line 2x plus 3y is equal to 10. So really important we understand the difference between our answers if lines are the same versus if lines are parallel. And our final example of this particular lecture, I'm going to go ahead and cancel out my x's, so I'm going to multiply by negative 2. So I would get negative 4x plus 8y equals negative 26. The reason why I chose to do x's instead of y's, if I chose y's, I would have had to multiply both equations by a constant, which just would have been a little bit more work and more opportunities for me to mess up. Okay, when I add these, my x's cancel out. I know negative 5y plus 8y is 3y. And negative 26 plus 8 becomes negative 18. When I divide both sides by 3, I get negative 6. Okay, so I know that I have half of my answer. To get the other half, I'm going to go ahead and substitute into the first equation. Remember, it does not matter which equation I choose to use. So in that first equation, I'm just replacing y with -6. So I get 2x plus 24 equals 13. When I subtract 24, I get 2x equals -11. So x is -11/2. Okay, remember, I should always be leaving things in improper fractions versus mixed numbers. Mixed numbers are evil and bad, and we don't like them. The only appropriate time to use those in algebra would be if we're answering a word problem, because then it would make more sense to put it in that term. The other appropriate answer here would be -5.5, because this is an exact decimal. Okay, so if something is not exact, then I should leave it as a fraction. Okay, I'm going to leave it as a fraction in here. Let's double check this. Especially, I think when we get a fraction, we start to doubt ourselves. So it's really important to check to make sure that we are correct. When I substitute in, I get -11 plus 24 is 13, which is true. In my second equation, I get -22 plus 30 equals 8, which is also true. So this is linear combination. A lot of the times on our test, it'll specify like use substitution, use graphing, use linear combination. And sometimes it'll say use whatever method you think is easiest. That's why it's important for us to start thinking about why a particular method would be easier to use on a specific problem.